Alright, so let's quickly talk about the bump map node. So this node, we'll just grab bump map, drop it in. Using this guy, we'll be able to apply bump maps and normal maps to our shaders. So the way we use it is take the out and pipe it into overall bump input on the Redshift material node. Now we're going to start off with a bump map, which is a black and white map. Let's just take a look at that real quick. And we're going to zoom in on this guy. So this object has no UVs, so I went ahead and used a triplanar just to project the texture. You can check this guy out in the triplanar section. So I have this black and white bump map, and I want to plug it into my shader as bump. So all we do is take that guy, plug it into texture input. Now let's take the material and pipe that out to the surface, and we're going to see this nice bump, which leads me to the first option in the bump map shader, input map type. So right now we're on height field, which is expecting a 0 to 1 value in your map, i.e. black and white. Has a couple other options, but we'll go over those in a second. So height scale is just a multiplier on the amount of bump that the map is going to influence on the surface. So if I half this, you'll see there's a lot less surface disturbance. Now it's important to note that if I crank this guy really high, we're going to get unusable results because the bump map is only affecting the surface shading of the object. It's not actually displacing the geometry, creating shadows and such. So if I look at this guy from the side, you'll see we're not actually displacing the surface, we're just simulating the effect of displacing the surface. So if I turn this back down to 1 or maybe 0.5, kind of liked how that was looking, we're simulating the effect of anywhere that the map is white is bumping out of the surface. So let's say if we take a look at just this little guy right here in the center, when I flip back to my material, we'll have a little bump out, what looks like a bump out there. So next up is affected by object scale. That just means if I scale this object up or down, it's also going to scale my bump accordingly. So let's just say this guy, again, represents a displacement of 1 centimeter outward from the surface of the geometry. Then if I scale the model up by a factor of 2 to be twice as large, that bump is now going to represent 2 centimeters outward from the surface of the geometry. And then of course we also have the remap options, which just let you clamp down or expand the range of your bump map. Alright, so let's talk about those two other options under input map type. We have tangent space normal and object space normal. You're really only likely going to ever use tangent space normal, which is the format that most normal maps that you're familiar with will come in. It's kind of very light purple. And this basically just tells Redshift that, hey, if you're this purple color, that means I'm facing directly at the camera. But if I'm any of these other color variations, I'm actually facing a different direction. Now, object space normal, on the other hand, is not referencing the direction that the camera is facing. It's referencing the coordinate space of the object. And those kind of maps tend to look like this, with these pinks, greens, yellows, blues, all very separate looking. But I imagine you will rarely come across those. So let's go ahead and choose tangent space normal. And we're going to go ahead and plug in our normal map to the input of the bump map. And let's pipe our material to the output. And maybe we'll set our height scale to 1, which is what this comes at by default. Now you can see I've got this very nice fine bump detail here. It's very important to note that you need to make sure that your normal texture is coming into the bump map in linear color space, which means if your normals are a JPEG or PNG or anything that Redshift is going to think has an sRGB color profile, you're going to need to tick enable on gamma override and make sure the gamma is set to 1. So moving back to the bump map node, we have unbiased normals, which again you'll probably never need to use. The only time you'll ever use this is if you know that your normal map represents a range of -1 to +1. So if I have my geometry surface here, most normal maps are mapping height details from 0 to 1. So if this is our surface and our bump comes out this far, our geometry surface is represented by that light purple color. And the other colors you see represent the bump normal directions. Whereas if you're using unbiased normals, you can also have negative values which represent inward into the geometry. Long story short, only use unbiased normals if you know that you have unbiased normal maps. Lastly, we have flip normal Y, which just says, hey, flip the way that I think up is. So if you have a light from above, you'd be casting a shadow downward. Whereas if you have flip normal Y and your light is still above, it's actually going to cast the shadow upward. And this can be useful just in some applications that you might be exporting normals from, or maps that you might purchase may sometimes come with the mapping of the y-axis flipped, and this just allows you to fix it.